Okay, so Artur will continue the topic of retrievals, but probably in a slightly different context. Please.
Here? Okay. Hello, my name is Artur, and I'm an ML scientist at Picsart, specializing in search and recommender system. And today I will present you how to leverage LLMs and textual embedding models to build domain-specific information retrieval system. For those who don't know, Picsart is a photo editing app with millions of users, and search is a main place for users to find inspiration, find the image they want to edit, and to build their visual content. And our goal is simple: bring relevant content to user, even if their query is messy, noisy, or just in another language. And this is our application, and before going to methodology, first, why we need vector search in the first place? The current problem with keyword search is that they only bring documents with description contain words of the query. So it's very limited. For example, it couldn't retrieve the description which contains synonyms, similar words, or abbreviation. For example, if in my document is written K-pop, it couldn't retrieve for Korean pop, or it's written kitten, it couldn't retrieve for cat. And that's all a limitation. And also, if I write query in Russian or Spanish, it couldn't retrieve English-related documents. And this is how document in the Picsart. We have image, and we have list of tags, separated some commas, some hashtags, which are quite messy. Even our document have some messiness and we need to bring something relevant to users. We won't just bring full image document, but also want to find content that have thematically similar to the given content. And there is an example that if I write with typo, keyword search couldn't return, but for example, vector search can. Because vector search capture not only as a sequence of letters, it captures semantic word. It understands, for example, that Call of Duty and Battlefield both are related to game, and even if he couldn't return content that exactly relevant to a query, it can be relevant query. So now for vector search, the main component is to finding textual embedding model. How to find the most relevant that are specific to our domain's use case. There are currently external benchmark on which a lot of embedding model was evaluated. And the most popular one are MATLAB. But there is a limitation of this benchmark. First of all, they were evaluated on the different data sets that have domain mismatch to ours. Either they are very generic or have some domain, for example, chemistry or physics that have no connection to our domain. And that's a problem. For example, their query can be whole question. In our cases, it's just word of 2 or 3 words, which have nothing common. And also their document can be whole a paragraph. And in our case, it's just a bunch of words, tags, and they are somehow related to each other. So that's a problem. We have that embedding models that evaluated on external, and our case are not similar. So what to do? We need to create our internal data set to evaluate these models. That's how we did it. Currently, as I said, we have only search that only return documents that have fully matched with queries. What to do? First, we collected all popular queries from our data lake that user mostly used and try to augment it. First of all, let's find queries that are similar to our queries. For example, cat is a kitten, can be code is Call of Duty, etc. So we are finding very similar query to my target query. And for this query, I'm extracting relevant fully matched documents. So what we have, or query I have first, document that currently our search is showing is a full image, then coming documents that have similar node but not exactly. And what else I want to do? I want that also if I can't bring relevant document to current query, I want also to show documents that are thematically similar. For example, if user write Minecraft, but I don't have Minecraft, I want to bring something related to Roblox. And I'm also collected semi-similar queries for this target query. And as for any ML task, I need also negative data set. So I also collecting dissimilar queries and corresponding dissimilar document. So this is one of example of my data. I have cat. For this, I collected relevant document which contain those cat words. Sorry. And I'm finding similar one with a kitten, and I collected this data set and then coming semi-similar queries and corresponding data set. And also dissimilar, which have nothing common with these queries. So I want that my vector search, my evaluation, come in this order, fully matched, then coming similar, dissimilar, semi-similar, and then dissimilar. So the main I'm first retrieving document, but also ranking them by user preference. So here I'm using user signal to understand even sometimes document is just bunch of words, but we want that if have some words have related, I want to bring it top. So I want to capture this user preference in my ranking too. So what I have done, I created a graded relevance data set, which capture user preference. And current benchmark is lack of that. The current benchmark just have query, relevant, non-relevant document, which doesn't show intent of my user. So as I said, currently most popular benchmark for evaluating embeddings is MATEP. I take top 10 embedding models from this MATEP leaderboard to evaluate it on my internal data set. But also I choose OpenAI one, which is not free, but want to compare as an external unknown model. I mainly choose models with medium size because I want my vector search to be real time. I want the user don't lagging because the main problem with big models, they can take a few seconds of inference, which is unacceptable in application, and we have user dissatisfaction, and that's a problem. But for evaluation, I choose two biggest models to understand how far these medium-sized models from limit. So choosing these models, I make evaluation setup. Mostly metrics that are used for this evaluation are currently known metrics: NDCG, map, precision, and recall. And evaluation on this, evaluated these models on my data set. Surprisingly for me, the model that he mid-side compared to Qwen is showing it outperforming in the metrics in my data set. So even if you have big model that train a lot of data, have big capacity, it doesn't mean that this model can evaluate better on your data set because there is always domain mismatch. Even second place, I have model that's 4 times smaller than first one, which is very teeny and very good for real time, is again outperforming big models. So leaderboard doesn't equal to your domain leaderboard. And also I make evaluation on queries with typos and translation. For example, if I make typo and query, it should return result in the same order as in the correct query. So again, on that evaluation, this 2 Stella model again win, and translation didn't win, but on the second place. So again, it's showing a good result on my data set.
Artur, these were on your data set, these numbers?
Yes, all down is our Picsart internal data set, which have user preference, user queries, and user document.
I see, perfect. So, and this layered graded approach is included in the
yes,
NDCG?
Of course. Yes, NDCG. Mainly score is here in DCG. Because I want fully match come here, then similar, then semi-similar. And that's my main target. Okay, now what we have. For every query and every document, I have scores. But there's a problem. Matching and retrieval in the vector search and ranking is the same. So I need somehow, after getting score, to cut off, after which I don't want to show any content to user. So don't bring relevant content. If I set this threshold too low, I'm risking to showing non-relevant content. If I'm risking too high, I'm losing recall, but have precision, but again, can be dissatisfaction from user side. So what to do? I have, as I said, this graded the data set, and I want some function which will give reward for showing fully matched, similar and semi-similar document, but I also want to penalize for showing dissimilar documents. And what I also want, I want that if return nothing this threshold, I want also to penalize this. So here is come help, Cobb-Douglas formula from economy, which helped me. It is a utility function, as I said, which giving reward for similar and penalizing for the dissimilar document if I retrieve using this T threshold. And there is also parameter alpha, beta, gamma, how much I want to give reward or penalize for current threshold. And of course, this threshold for every business case, every application is specific. For our case, it's another, and your case can be absolutely another. And after all this, we optimize this utility function and find our threshold that is currently best for us. And there is after this research, understanding threshold, collection data set, what we understand that if there is some leaderboard that's showing very good result, for example, now Gemini, OpenAI, we have very cool LLMs embedding models, it doesn't mean that it will work on your use case. Your domain specific doesn't reflect user generic specifics. So that's why you always need to collect your internal data set with your user preference, with your queries, with document to understand how well this or that embedding model will work on you. So leaderboard never equal to production performance. And also you can have very big model with a lot of capacity, but it's not thing that will go to production. It's awful big and slow. So what surprised for me that small models can again sometimes beat larger ones, which show in the table. And also for currently benchmark, as I said, there is a problem with binary data set. They only say relevant, non-relevant, but mostly user, even if they can't exactly they want something similar. For example, in the Netflix, if you wrote Harry Potter, it will never show it, but it will be TV series related to magic. And that's the user satisfaction. And as I said, Stella models fit to our domain case. It's robust both typos, noisy queries. It can work in real time. And it works in other languages too. And also this methodology, how we collect data set, how we choose model, that is transferable to other domains, because what we need, you need your data with your specific domains. And after collecting all that, build our system with our vector search, we want to understand, do we need all this? Maybe our current users are already satisfied and don't want something new. And that's why we are conducted A/B to see how this search, keyword search that we was implemented, and vector search are comparable. We won't compare them. And in this A/B, we could win. We show increase in user metrics, and that was proof for us that we needed vector search. Thank you.
Thank you.
Sorry, it was a bit faster.
No, it's good. One thing I wanted to understand, when you say you have user preference data, how do you collect that? Or it's not shareable?
For every query.
Like I query, like I use Picsart, I searched, and I clicked on it. I clicked on something.
Yes.
How do you know that I am satisfied with that?
Because you click on it. If you, for example, you are seeing 10 items, right? And you click one of these 10 items, but you see, say others. You have view, but don't have, but only one of these 10 have click.
What if I didn't like and came back quickly? Like, do you consider these things? Like, I think in Google, if you click and in 5 seconds go back to the same search page, Google considers that you didn't like it.
Yeah, that's why we have a lot of metrics, not on click. For example, if you clicked, you won't go editor. If you, for example, edited, you apply it. That's another strong signal. And the final signal for us is the remix. If you use the remix and post it, it's a very strong for us that user really like this image.
I see. So you use complicated downstream signals to... Okay. Do we have questions from the audience?
Thank you for presentation, Artur. You showed how to choose out of the existing pre-trained models, the one that is fitting your domain specific settings. Why did you stop there? Why didn't you go to the training on this domain specific data, Artur?
Because it's costly, David.
I think it's not so costly, I think.
Yes, in fact, it's our next iteration. We have baseline scores on which how perform model on dataset, and our next goal is to go further to fine-tune our currently this model on this dataset to understand where we could go.
Okay, thank you.
Other questions? Do you know how easy it is? I mean, easy. When you have the actual data, because like people when are asking these questions, like which kind of embeddings I should use and so on, and they have zero data, they just starting a new company, but they have nothing, and then I'm like, how do you know? Like you first need to do this, what you just described. This, in that sense, this is a very good presentation, very kind of educational. You need to get the data first, then check whatever exists on Hugging Face, and then, if it's not enough, please start to train. But people start usually from the other end. Which optimizer should I use to train this? I'm like, why?
If you are working in industry, first thing is come data, then model. If you are not, if you are a researcher, maybe model is come first. But if you are
in fact, in research, it's the same, but it's just researchers do not like to do that, so they stick with existing data.
Maybe a practical question. When you went to the vector models and vector databases, how much your latency suffered and how much more the price of each search went up? Because I think vector databases are much more expensive.
I can say that latency increased, but can't say how much. But yes, it's difficult. The second problem, not problem, but challenge was to find corresponding database for vectors, because not all database support it. And if they support, they are very slow. You know, there is phase maze, a lot of algorithms to store embeddings, and there is no current best solution how to store embeddings.
Well, there are Pinecone and there are specialized vector databases and providers.
Yes,
right?
but they are not good. For example, I checked Milvus, and it's not for me production ready for millions of users.
Thanks.
Oh, interesting. Okay. More questions? Okay. Oh, yeah, Arsen has.
Just continuing on the previous question, if it's not a secret, in that case, which vector database do you use?
Oh, I don't know whether can I say or not. Currently, we are using OpenSearch, which are fork of Elastic, which provide robust retrieval and not big latency.
Okay, thank you.
Okay, interesting. That's it. Okay, let's thank Artur again.